All right, so yesterday we were looking at this calculation, and what we had, like we started looking at B, and then we got the wrong answers, and I was trying to figure out why. And remember, we're supposed to go to each joint with the least amount of unknown items. So if we're looking at, we went straight to we did this, like solved this joint completely, solved that joint completely, and found all these forces that have arrows. Here I have an unknown force at a diagonal, and same with that, which means in this, for joint B, I have an x and a y component that I don't know, so that's two things, and then I have another x and y component that I don't know. So that's four unknown items here. Whereas if I looked at joint C, or joint D or E, then let's see. Well, I have an unknown diagonal, which means I have an x and a y component, so that's two unknowns, and then just an x component, so that's just three unknown items. So I should have worked on D or E next, and I think that will help get rid of our error. So instead of working on B, we did this because we knew a lot about it. This reaction force in the x direction was 0. I have my list still, and I'm just going to use whatever I can to find the rest: dB, dE, and BE, the forces within those members. So remember, you're going from the most or the least amount of unknowns onwards, so that decides what you can do first. And that's why I won't do B next. I'll do joint D. So I'm going to focus on joint D. And let's draw the free body diagram for that. I know that the force pulling down was 1,000 pounds. 1,000 pounds. And then I have the force of AD. That was 13789. 137.8. Right, pounds, okay, that's a 0. And I have just a single x component and an x and a y component here. So I don't know which way this one points, or the other one, but let's see here. I know that this has an x and a y component. What is that? That's the force within dB. So F, D, B, x, there's an x component, and F, D, B, y. Now I also know that I have component forces for A, D, right? And this is how I can figure out the rest of this. I need to figure out the y component, because right now this will cancel out with some of this, and then whatever's left over has to be taken care of by the y component of dB, just because there are no other y components for this joint. So if these aren't already balancing each other out, then this has to do some kind of resistance force or whatever. So what we're going to do first is find the force within the y component of AD. So AD, y. So that's what I need to know. And we'll see how much of it gets canceled out by that 1,000 going downwards, because this is definitely going upwards. So let's see. How do we do that? Well, I think we need that angle, and I also think we can find that angle. So I'm going to draw that triangle, and that angle, well, this was 3 feet. Yeah, I think we already did find that angle. And this was 3 feet, so this was 45 degrees. So now I can find my x and y components are going to be the same, but I can use SOHCAHTOA to find my x and y components here. So that's what I'm going to do. I guess I'm finding the y, so I have, 1,378.9 pounds of force. This is 45 degrees, and I'm looking for F, A, D, Y. So I'll do sine of 45 equals F, A, D, Y divided by 1,378.9, multiply both sides by 1378.9 to get rid of that. 378.9. And then the force of AD, right? That's AD, correct? Yes. The force of AD in the y direction, that'll be in the positive y direction. That'll be 975.03. I'm just going to round it to a whole number. 975. So 975 pounds. And I know that for this joint, this y component plus this y component, some of it will cancel, has to add to this y component to be 0. So I know that this is going to be positive. I have the 1,000 pounds of force being negative, so I'll have that on the other side. And so this is positive, so 975. That's positive plus, well, I guess if this is negative, this one has to be positive, right? What's left over? What's left over? That's what I'll do. What's left over? So I have 1,000 pointing down, so 1,000 pointing downwards, and I have 975 pointing upwards. So I'm left over with 24 point, it's 9, 24 point, that's 25, I'm rounding it up. 25. Alright, so I rounded that one. So 25 pounds has to be facing upwards, because this is 1,000 pounds. It's stronger than this force is pulling upwards, so this needs to help it. So there we go. I figured out the direction. That means this has to be pointing upwards, and FDBY is 25. FDBY is 25 pounds, and it's in the positive direction. FADY, I already figured out that's 975 in the positive direction, pounds. And yeah, well, I can use that and find FDB now, right? Actually, I probably can't. What do I need? Maybe I just need FDBX, and then I can use Pythagorean theorem to find FDB. I think that's what I do need. So let's sum up all the x components. Right? We did this plus this to get that. Well, let's do now this plus, well, I know now this is pointing this way. This, and then I'll figure out what that needs to be. Right? If these are perfectly balanced, then the force within this member has to be 0. If they're unbalanced, this member has to make up whatever the unbalance is. So this is summing in the x direction, and I know that component will be that way. So I guess I need that one. What is that one? That is FAD in the x direction. So I need FAD in the x direction. God, these take so much. They take so much. So how do I do that? Well, I can still... Oh, I already know that, right? Because that was the right triangle. So that means FAD in the x direction is the same as that, 975. FADX, that's 975. Didn't we find that already? I don't know. Pounds. So that's cool. And that's in the... That's to the right. So that's going to be positive. And this one I already know is to the left. So what is that? FDBX. That'll be to the left. Right? Correct? Or not right? Alright, whatever. Well, I can't really... Whoops. Undo. I can't really find that x component. Maybe I can just find the actual force, FDB, using trig. Maybe. I already know that this triangle right here has 56 degrees. We figured that out in class, I think. I'm pretty sure we did. So that would be 56. And we do know the y component. And the y component is pointing upwards. and that was FDBY, that's 25. So maybe if I use 25 pounds, if I used sine, this is FDB, sine of 56 degrees, that will equal opposite over hypotenuse. I think that will help us. 25 over FDB, the shortcut is to just switch those. So FDB equals 25 divided by the sine of 56 degrees. There was a decimal there, but I'm rounding stuff off so I can go faster. FDB equals, okay. So FDB equals, hey, this is correct. Hey, 16 pounds. Sweet. That's what I needed. I definitely needed that. FDB. Where's my list? FDB 30.16 LB. Oh, and I know that this is in that direction, so that means that's there. And that means, what is it? Pushing, so that's under compression. Sweet. So that's under compression. And then I can find out the rest of the stuff here. Oh, nice. This is beautiful. Beautiful, beautiful, beautiful. Well, since I have that, now I can also find the x component. There we go. Now I can find the x component and see what that is. Shoot, I can't finish that in this video. You know what? We'll finish it in class. It's already scattered anyways. We'll go over this again. It's taking longer than I expected, but sorry.